Hey everybody, and welcome to this screencast on theoretical probability. So the goal of this particular video is to help you determine the theoretical probability of any event and using different strategies. So you use some mental reasoning, you'll see tree diagrams, as well as something that might be new called complementary events. So let's have a look at, let's say, a definition for theoretical probability. So we started looking at that in class. And we may have come up with the following. So it measures how likely something will happen, and it's represented as a ratio. So the ratio is the number of successful outcomes, meaning what is it that you're looking for compared to the total number of possible outcomes. So we talked about some different examples in class. Quick one being, if you're rolling a die, that's a single one, and you're looking for the number of, say, odd numbers that could turn up. Well, there's 3 successful outcomes, and there are 6 possibles. So 3 out of 6, or 1/2, would be your theoretical probability. All outcomes are equally likely. So in the previous example, if you're looking for those odd numbers, each of those has an equal chance. If the die is fair, right? If it's fair, then those numbers have an equal chance of coming up. Moving on from there, let's give that definition a bit of a workout. So here's an example. So let's see if we can determine the probability of drawing a heart, club, or spade from a standard 52 card deck. So what I would have us do is to apply that definition. So successful outcomes compared to possible outcomes. So that means if we're successful in drawing those cards, that we need all hearts, clubs, and spades, which is 3 groups of 13, and divided by a total of 52. So in total, we'd have 39 on 52. Okay, and then in lowest form, something you should always try to do if possible with fractions. So I believe both top and bottom are divisible by 13. So if we divide the top by 13, we'll end up with 3 as an answer. And if we divide the bottom by 13 as well, we'll end up with 4. Okay, so 3/4, and this makes sense. 3/4 of the suits in a deck of cards are made up of hearts, clubs, or spades. Something else you need to consider too is the following. Is sometimes you're going to see probabilities calculated and are represented in other forms of numbers, so specifically decimals or percents. So this one here is a common fraction, or a benchmark fraction. It's one we're used to, so that would give us a decimal value of 0.75. So dividing the top number 3 by the bottom number, or denominator 4, gives us that, which is also equal to 75%. Okay, moving on. So a second example is, depending on the type of question you're dealing with, you might find that there are different strategies. And each of those strategies has a particular usefulness to it, okay, depending on how much diagramming you need to do with the question. So some questions just beg the use of what we call a tree diagram, or a table of outcomes. So let's have a look at this one here. It says, how many possible outcomes are there when rolling a pair of dice? Okay, so a pair of dice. So what we're going to do is we're going to have a look here. The start meaning this is the roll of the first die. So on each particular roll, right, we have 6 outcomes. So 1, 2, 3, and all the way through to 6. But what you're going to notice here under the note is the fact that each of these branches, okay, has a probability of 1 on 6. Okay, so that is each particular outcome has that probability of 1 on 6. And then all together down here, if you were to add those numbers up, okay, 6 1/6 will give you 1 whole. And that makes sense because we're bound to get a result, right? The number's going to come up if we roll that die. Now, on the second event, right, this is what we would call the first event. And the first event was rolling a die, okay, a single die. Now, the second event occurs when we roll the second one. Generally, these are done simultaneously. So what you can see and appreciate is the following, is that on each particular, off of each first event, what's going to happen is we now have a possibility of 6 outcomes off of each of those outcomes from the first event. Okay, so we really end up with 6 groups of 6. You'll have to excuse the phone here as I'm recording. Okay, so each of those has a particular set of outcomes, so 6. So my question here, okay, or rather statement, is the following. So as you noted in what I was saying, is that the tree diagram shows 36 possible outcomes, which means that if you were to add those pair of die, then there should be 36 possible sums. Okay, so let's take a look at a visual that's going to put that together for us. Okay, so we're going to use a couple of visuals to solve this problem. So the example being, what is the chance of rolling a sum of 8 or greater on the roll of a pair of dice? So here are 2 things you might find handy. Okay, this does look a bit busy, but really what it means is by rolling the first die, and here are the possible outcomes, and here's the second die's possible outcomes. Each of these pairs or ordered pairs, okay, can be combined to create a sum. And this particular graphic here is the result of combining those. So this is a table of sums. So as you can see, this 6 by 6 array gives us 36 sums. And across the longest diagonal, the 7s represent the most frequent sum of all. So if we're to solve this question, let's get this graphic out here now. So what you can see is that of all the outcomes that we have, those that are 8 or greater, you can see the 8's all here, and all those sums greater than that lie in the lower right-hand corner. So there are 15 successful outcomes in relation to 36. So with our formula, we'll say the probability P of a sum greater than or equal to 8 would be 15 on 36. And in lowest terms, if we divide the top and bottom both by 3s, we'll end up with 5/12. And as a percent, 42%, or a decimal of 0.42. Now, last but not least, there is one other technique that I think you should be aware of, okay? And it's handy for solving particular problems where you have a lot of probabilities to calculate. And I'll show you what that's all about. So let's say that you're being asked, or you're thinking of the complement of an event, okay? The complement is the event really represents all other events. So really it's not what you're looking for. Okay, so for example, the complement of pulling a red card would be pulling a black card, right? The complement of rolling an even number would be rolling an odd, and so on and so forth. So sometimes it just makes sense, or is much more helpful, to calculate what you're not looking for in order to find what you need. Okay, now it might sound a little strange, but here's an example, a quick one, that shows how the complement can be useful. Okay, so I'm just going to follow the instructions here in this interactive file. So I'm just going to pull this tab out and notice that, okay, what we're looking for is the probability of not rolling doubles using a pair of dice, okay, of not rolling doubles. So notice that the doubles only occupy a certain diagonal, and there's only 6 of them, okay, whereas the remaining values in that array are all non-doubles. So instead of trying to figure that out directly, okay, what we can do, the probability of non-doubles would be the same as taking the probability of getting doubles, which is only 6 of them, and subtracting that from 100%, or 1 whole. And what that does is it leaves you with the following. So take 6 out of 36 outcomes, which are doubles. That's not what you want. And subtract that from 1 whole, or that is all of the 36 possible outcomes. And what you have as a leftover, or that is a difference, is 30 on 36. Okay, and you can quickly see that through the table that 30 outcomes are not doubles. So, in lowest terms, that would be 5 out of 6. Okay, so for every 6, 5 will be non-doubles. Okay, so that brings our video to a conclusion. And what you'll see coming up next is you have a few questions related to this, one involving the complement, another one involving a tree diagram. So you can do that on paper and pencil, or if you prefer, you're going to find that in your OneNote content folder.